In this video, we're going to use Stata to conduct a simple test of an hypothesis using a test called the t-test. We're going to use a data set called Dragonfly Data, and I'll double click on that to launch Stata. You can find a copy of Dragonfly Data on the biology webpage. Just go to the Scientific Writing and Statistics link and you'll be able to download a copy so you can follow along with this exercise. So let's take a look at the data in the data browser, and we see we have two columns. The data actually are the number of dragonfly larvae per square meter in two kinds of ponds. Some are pristine ponds that are not in the vicinity of farmland where pesticides are being used, and 10 of them are in agricultural areas where in the upland areas there are pesticides being used that are washing down into the ponds. So our question is the presence of pesticides the cause of any change in abundance of dragonfly larvae compared to areas where no pesticides are present in the water? So to test this hypothesis, we're going to use the student t-test, and what we're going to do is to go up to our statistics pull-down menu and pick summaries, tables, and test. And this time we're going to pick classical test of hypotheses, and we're going to pick the two-sample mean comparison. We're looking at two different means, pesticides and no pesticides. So we'll click on that, and our first variable is going to be the no pesticide treatment, and the second would be the pesticide treatment. And our 95% confidence level is what we generally use in biology. So we're going to say OK. And I need to go back to my results window to see what's going on here, but in there are the data. So we have a fairly complicated table here, but to get to the most important part of the table, what we're going to do is to go down to this central portion here. So the question is, do we reject the null hypothesis? The null hypothesis, as you remember, is the hypothesis of no effect. So the null hypothesis would say that the number of dragonfly larvae in pesticide-contaminated ponds is equal to the number of dragonfly larvae that are found in ponds without any pesticides. What we see here is we've calculated a probability, and that probability is 0.0062. That's a very small number, and that number essentially says that is the chance that the differences that we saw between the two ponds could be due just to luck, just to chance, just to random effects. In other words, there's fewer than 7 chances in 1,000 that would have happened randomly. So what we're going to be able to do is to reject the null hypothesis, and in fact we'll claim that the alternative hypothesis is true. If we go up and look at our data here, we can see that in the no pesticide ponds we had an average of 32 dragonfly larvae compared to only 19.6. So we've used the student t-test, named after a statistician named Student. We've used the student t-test to test for whether or not this is a significant difference. And this p-value here is far less than our critical value of 0.05. Remember, in biology we mostly use that critical value as a sufficient reason to reject the null hypothesis. So any p-value less than 0.05, we would reject the null hypothesis. This number here is far less than 0.05, and therefore we feel very confident in rejecting the null hypothesis. And our conclusion, therefore, is that the presence of pesticides causes a reduction in the abundance of dragonfly larvae.